Yet again, NASA has affirmed that its shuttle, Pilgrim 1, right now the farthest human-made object in space, has started communicating important information to Earth. Albeit the subtleties of the article remain hazy, specialists can gauge its distance. Voyager 1, sent off by NASA over quite a while back, has recently sent back a shocking message that has resonated throughout the scientific community. After traveling nearly 14 billion miles from Earth, EXP Pioneer 1 has made a discovery of such magnitude that it has altered the course of its mission, prompting it to return toward Earth. This striking change in its path has ignited interest and speculation. Just minutes ago, Wayfarer 1 made a frightening discovery, causing it to shift its trajectory and head toward our planet. But what exactly has been found? Could it be evidence of extraterrestrial life, an unknown phenomenon, or something even more unfathomable? In this gripping account, we delve into these thrilling findings as Traveler 1 has made a discovery that has prompted it to suddenly change course toward Earth. According to records from the twin Voyager probes, certain celestial events had to align perfectly for these two remarkable spacecraft to ever leave Earth. Nearly 50 years ago, the four largest planets in our solar system began aligning in a way that had not been seen since Thomas Jefferson's presidency in the 1800s. This extraordinary planetary alignment remained largely unnoticed until Gary Flandreau, a doctoral candidate at the California Institute of Technology, recognized its significance in 1965 during the early days of space exploration. While working part-time at NASA's Jet Propulsion Laboratory, JPL, in Pasadena, California, Flandreau was tasked with determining the most efficient route for sending a probe to Jupiter or farther destinations like Saturn, Uranus, or Neptune. Using only a simple pencil, he meticulously charted the orbital paths of the major planets and made a groundbreaking discovery. By the late 1970s and early 1980s, all four planets were set to align in such a way that a single spacecraft could visit them all, utilizing gravity assists from each planet to propel itself to the next. This rare alignment would allow a spacecraft to reduce travel time significantly, shortening the journey from Earth to Neptune from 30 years to just 12 years. However, this planetary arrangement only occurs once every 176 years. Seizing the opportunity, NASA decided to launch spacecraft during the early 1970s to take advantage of this once-in-a-lifetime alignment, Voyager 1 and Voyager 2. These twin spacecraft embarked on an extraordinary mission to explore the outer planets of our solar system. Thanks to the alignment and the visionary calculations made by Gary Flandreau, the launch of these spacecraft on September 5, 1977, marked a historic event in space exploration. From Cape Canaveral, Florida, Voyager 1 began its grand journey into the cosmos aboard a Titan III Centaur rocket. Just 15 days later, Voyager 2 was launched on August 20, 1977. The primary mission of these spacecraft was to study the gas giants, Jupiter and Saturn, along with their moons. However, they far exceeded expectations, venturing beyond their initial objectives, traveling farther and longer than any other spacecraft before them, and breaking numerous records in their pursuit of discovery. They ventured into regions never before explored by human-made objects, even reaching what is now known as interstellar space, a completely unknown region of our galaxy. Today, Voyager 1 and Voyager 2 are more than 12 billion miles from Earth. Despite their incredible distance, they continue to astound scientists with their remarkable discoveries. Their latest findings have left the scientific community in awe. In the past, the twin spacecraft achieved a series of astonishing feats, including studying the moons of Jupiter and Saturn. These moons, once believed to be dull and cratered like Earth's moon, turned out to be dynamic, fascinating worlds. Voyager 1 made history by becoming the first of the two spacecraft to fly past Uranus in 1986. Just 3 years later, it flew by Neptune, achieving something no other spacecraft had accomplished. As these probes continued their incredible journey, NASA implemented various strategies to ensure their continued operation. They deactivated non-essential components, such as extra heaters and instruments, to conserve energy. The goal was to keep them operational at least until 2025. For the dedicated scientists and engineers who had been involved from the beginning, this achievement was a combination of hard work and emotion. At the start of their journey, the Voyager spacecraft amazed scientists with their first close-up images of Jupiter and Saturn's moons. These moons, which astronomers once thought were dull and heavily cratered like Earth's moon, turned out to be active and dynamic worlds. Dynamic universes. Voyager 1 arrived at Jupiter in March 1979, only 546 days after its launch, while Voyager 2 followed a slightly different path and arrived at Jupiter in July of that same year. Equipped with advanced cameras that could rotate slower than an hour hand on a clock, these spacecraft captured more than 33,000 detailed photos of Jupiter and its moons, revealing new and exceptional data. For example, the moon Europa was found to have a thick, icy surface with cracks over 60 meters deep. As Voyager 1 and 2 left Jupiter, they were slingshot to even greater speeds due to gravity assists, propelling them toward interstellar space. The two spacecraft then continued their separate journeys. Voyager 1 passed through Saturn's iconic rings and flew by Titan, a moon covered in an orange haze. Voyager 2, on the other hand, ventured to Uranus and Neptune. In 1986, Voyager 2 made a significant discovery at Uranus, identifying 10 new moons and confirming that the planet also had rings. However, its achievements were overshadowed by a tragic event. Just days after its closest approach to Uranus, the Space Shuttle Challenger tragically exploded during takeoff, killing all 7 crew members, including Krista McAuliffe, a teacher who was meant to be the first civilian in space. As Voyager 2 flew over Neptune's atmosphere, it encountered the highest recorded winds in our solar system, reaching speeds of up to 1,000 miles per hour. Neptune's largest moon, Triton, was revealed to be one of the coldest places known, with surface temperatures plunging to -235 degrees Fahrenheit. Additionally, scientists discovered frozen volcanoes on Triton that emit nitrogen gas and particles as high as 5 miles into the moon's atmosphere. After these astonishing observations of Neptune, both Voyager spacecraft were set to shut down their cameras, signaling the end of their official missions. However, Carl Sagan, an astronomer and member of the imaging team, advocated for an extension of the mission. This decision was driven by the hope that the spacecraft could continue their journey into interstellar space. The mission was then renamed the Voyager Interstellar Mission, and both spacecraft ventured further into the unknown. In August 2012, Voyager 1 reached an extraordinary milestone by crossing beyond the heliosphere, the region of charged particles created by the Sun. The following year, a study published in the journal Science highlighted Voyager 1's critical finding. The spacecraft's plasma wave instrument detected a strong solar flare between April 9 and May 2013. This event caused nearby electrons to vibrate, indicating that Voyager 1 had entered a region of higher particle density than the heliosphere. Although it may seem surprising that electron density is higher in interstellar space than near the Sun, researchers explained that the density of electrons at the edge of the heliosphere is much lower than on Earth. By analyzing this data, scientists pinpointed that Voyager 1 officially crossed into interstellar space on August 25, 2012. This achievement filled the team with immense joy. Mission Director Susan Dodd expressed her excitement, stating that the team was thrilled to see Voyager 1 reach this incredible milestone. Ed Stone, a key figure in the Voyager missions, emphasized how this breakthrough contributed to our understanding of space. He explained that Voyager 1 had helped scientists gain insights into the nature of energy and radiation beyond the solar system. Voyager 2 also crossed into interstellar space in November 2018, venturing into the uncharted region beyond the Sun's protective bubble. Now, here's the most astonishing news. After an incredible 46 years of space travel, NASA's Voyager 1, the farthest human-made object from Earth, is still transmitting valuable data. Despite being over 14.7 billion miles away, the spacecraft continues to operate well beyond its expected lifespan. This ongoing achievement, far surpassing expectations, is a testament to the durability and resilience of the spacecraft. However, NASA has projected that by 2025, Voyager may first no longer be able to generate enough power to continue transmitting data back to Earth. Recently, something unusual happened during routine communication with Voyager 1 via NASA's Deep Space Network. After more than 40 years of continuous data transmission, the spacecraft suddenly halted its journey and executed a 180 degrees turn. This unexpected shift in orientation has raised many questions and concerns. As scientists continue to analyze the data sent by the spacecraft, one mystery remains. What could be the cause of this strange anomaly? Only time will tell. Since the last update, NASA's Voyager 1 mission team has been working tirelessly to understand the cause of the spacecraft's unexpected 180 degrees turn. Given that Voyager 1 is over 14.7 billion miles away, communication with the spacecraft takes more than 22 hours for a signal to travel one way. This immense distance makes troubleshooting any issue a slow and complex process. Unraveling the mystery. Engineers at NASA's Jet Propulsion Laboratory, JPL, have been analyzing the spacecraft's data logs, looking for clues. Preliminary findings suggest that the anomaly might be linked to a malfunction in Voyager 1's attitude control system, which is responsible for orienting the spacecraft and keeping its antenna pointed toward Earth. If this system fails, Voyager 1 could lose its ability to communicate entirely. One theory is that aging components, operating far beyond their intended lifespan, may have caused an error in the spacecraft's thrusters or onboard computer. Another possibility is that cosmic radiation, high-energy particles from deep space, may have interfered with Voyager 1's electronics, causing an unexpected command execution. Despite these challenges, the mission team remains optimistic. They have successfully corrected past anomalies by sending software patches or switching to backup systems. However, with power levels dwindling, the margin for error is smaller than ever. Voyager 2's parallel journey. While scientists work on Voyager 1, its twin, Voyager 2, continues its journey through interstellar space, now over 12 billion miles from Earth. Unlike its sibling, Voyager 2 has been operating more smoothly, though it, too, faces diminishing power levels. To extend its lifespan, NASA has already begun shutting down non-essential instruments, prioritizing critical data collection on cosmic radiation, plasma waves, and interstellar magnetic fields. A legacy beyond time. Regardless of how long the Voyager spacecraft continue transmitting, their legacy is already cemented in history. These probes have provided humanity with groundbreaking discoveries, from the first detailed images of Jupiter's stormy atmosphere to the surprising ice geysers of Neptune's moon Triton. Moreover, both Voyagers carry the famous Golden Record, a time capsule designed to communicate the story of Earth to any extraterrestrial life that might one day find it. The record includes music, greetings in multiple languages, and sounds of nature, offering a snapshot of human civilization. The final chapter. As Voyager 1 continues its silent drift into the unknown, its fate remains uncertain. Will NASA find a way to correct its mysterious rotation, or is this the beginning of the end for the most distant human-made object? Even if Voyager 1 eventually falls silent, its journey will never truly end. It will continue traveling through the cosmos for millions, perhaps billions, of years, carrying a small but powerful message from Earth. We were here.